So let's take a look at some more with linear regression and where it comes from, what it means. So I have some data here from the US states data set that came with the book. And I'm looking at percent with a college degree, which in the original data was just labeled college. And then there was another one in here called household income. So more specifically, it's the percent with a college degree in a given state and the average household income in thousands. So for example, the 43 here means the average household income in Alabama is about 43,000 and about almost 25% of the people in Alabama have a college degree. When I look at the data, I see an uphill trend here and I ask Google Sheets to graph that line with me. For me. And I also asked it to state the parameters of the line. The parameters are the slope, 0.98, and the y-intercept, 23. I can also calculate those, so I went over how to do that before. Let's clean those up just a little bit. Oops, we need less decimals. 3 should be good enough. So here are the values for the correlation coefficient R, and remember that's the Carrel function. Y values, then X values. Slope is just slope, and the y-intercept is just intercept, which are the values in the graph here. The linear regression line finds the line going through the point that minimizes the distance vertically between each point and the line. So I just want to go over what that means. The idea is called the residuals. I'm going to show you what the residuals are and how to calculate them. So let's get a screenshot of this sucker. And I think I'll blow that up a little more. So again, the calculation for this line right here, we're trying to minimize the vertical distance between each point and the line. So imagine all these vertical distances. Now I'm not going to draw them all, I'm just going to draw a few of them. Every point has a vertical distance to the line. Some of them are very close, very short distance, but some of them are a little farther out there. So any other line you were to draw and then calculate all those vertical distances. These vertical distances are called residuals. Residual, there we go. And we would find that this line drawn by the computer has the smallest sum of all of the residuals possible. There's no other line that does a better job. So a residual, to calculate that, well, this point has a y value and this line has a y value right there. So it's just the y value from the data minus the y value from the model, which we call y hat, right? Another way to think about it, it's the actual y value minus the predicted y value from the equation. So in my spreadsheet, I'm just going to calculate based on the slope and the y-intercept, the predicted values, which are all the values on this line for any given x value. X values are the numbers on this axis here, percent college degree. And then if I take the difference between the original data and my equation numbers, that's what's called a residual. And then why do we care? So in this case, I'm just going to use the approximate numbers given right here. So this is a line. The equation of a line is y equals mx plus b. So equals m, 0.98, times x, that's my college degree value right there, plus b, and I'm just going to type 23.066. So these are predicted values. Google says, shall I fill them down? I could say yes, but I'm going to say no. And just fill them down manually by using that little autofill button in the bottom right corner there. All right, so those are all the predicted values. So sometimes if a state was close to the line, the predicted value will be very close. And if the state was far away, then the predicted value will be farther away. Now, if a point is above the line, that means it should have a positive residual because it's above the line. So to make sure you get that right, when you do the calculation for residual, it's always the actual y value, that's my average household income from the data minus the predicted, which is from the model. So Alabama must have been, its point must have been below the average. And this line draws like an average for all states. Okay, so that's another cool thing about the line. And I'll go for the autofill, sure, why not? So you can see some of my residuals are positive and large. Some of my residuals are quite small. Like Arizona is pretty close to average, which is on the line. Now, when we do a linear regression, I mentioned earlier that we do it under certain conditions. One, that we look at a scatter plot and we see an association, some kind of trend in the points. Two, the trend appears to be roughly linear. And three, there's no really crazy outliers. So this point appears a little high compared to the rest of the points, but I'm just going to claim, nah, there's no outliers here. I'm just going to go with it. So if I meet those three conditions, then I can say, yeah, let's run the regression, which means calculate the correlation coefficient, calculate the slope, calculate the y-intercept. And you can do that on a graph, or you can do that with these calculation commands I had earlier. Now, next thing I want to see is, do the residuals have any kind of pattern, or are they kind of random? If there's a pattern, we have a problem. If they're random, then we're okay. So to graph the residuals, I need the original x values along with the residual values as my new y values. To do that on a spreadsheet, you can just highlight one column with your mouse or touchpad, wherever you're using. To highlight a second disconnected column, you hold Control and then highlight the other ones. And then let go of everything. So I've highlighted those two disconnected columns. It takes a little practice, and then I'm ready to make a chart. And here's my residual chart. So for each x value, this shows how far the points were vertically from the line. And when I look at that, there seems to be slightly more points below, mostly because I have a few points that are further above than below, like these three, for example. But otherwise, it looks pretty random. I really don't see a pattern going on there. So what that means is it's more evidence that it's okay to calculate the regression line and try and use it for a prediction. And again, what does it mean to be a prediction? It means to use this equation, M and B, to make a prediction. So if somebody says, hey, this particular region in the US has about 35% people with college degrees, I could then plug 35 into my equation here and say, oh, well, then I would expect the average household income to be whatever it calculates out to be. You can also go the other way. If somebody says, hey, this region has an average household income of about 55,000, what do you think the percent of people with college degrees is? So I could reverse my equation to calculate that too. Okay. It's kind of cool. So residual. Residual is, after we calculate the linear regression model, we use the slope and the y-intercept to calculate a new y value, the model or predicted y value. If we look at the difference between the actual and the predicted value, right, that is that distance vertically between each point in the line, that's the residual. And the residual is simply the actual data y value minus the equation y value. Hope you found this helpful. Take care. Do good math. Adios.